Hello and welcome everyone to the first ever Brainfood Talk by Square on the topic of patterns to decompose monoliths. My name is Clemens Stift. I'm a software engineer here at Square, and today I have the pleasure to introduce you to this new format. So, first off, just one or two sentences about what this is. Square internally, we put a lot of weight on sharing what we learn in our projects with the internal community here so that we can all improve together. And the idea of these brain food talks is now to take our internal concept of the brain food sessions and share it with the broader software engineering community. And with this, today, we're starting off. I have two notes before we go into the actual presentation and into the actual content by Christoph, which is first off, we are live, so we have the pleasure of actually taking questions from the audience. So please just, if you have any questions, write them down as we go along and put them into our YouTube chat here. And second, we're live, but we will also be available afterwards. So of course, this live stream can be pulled on demand afterwards. Now, without further ado, I would hand over to my colleague Christoph Havlicek, who's had a lot of experience in decomposing monoliths in various projects and various companies. Christoph, take it away.
Well, thank you, Clemens. One sentence to myself or to my person. My name is Christoph Havlicek. I'm also a software engineer at Square here. I've worked as a software developer, as an architect, and I have the questionable joy, or the questionable pleasure to have a lot of experience by decomposing monoliths. And that's why I'm happy to share today with you some of the patterns we here at Square utilize to tackle these topics. So first, we start off with the disclaimer, of course. This presentation will not claim that monoliths are bad in general. This presentation is going to talk about how to dismantle monoliths that are in dire need of refactoring, but not all monoliths share that fate. There are a lot of architectural patterns that can be applied within monolithic applications, which enable monoliths to thrive and live just fine. And we also know that there is no architecture without trade-off. So even if you dismantle your monolith and you have suddenly a distributed systems can be difficult or challenging as well. We here in this talk is going to assume that you out there have a monolith, that out there is a monolith that is in dire need of refactoring. And we also going to assume that the refactoring is going to result in some form of distributed target architecture. What kind of distributed architecture out there we don't gonna talk about today because we only have 40 minutes. So without further ado, let's jump right in. So what does constitute a monolith that needs to be refactored? So usually one of the best metrics is collective pain shared within an organization through coupled monoliths. What I'm talking about is large-scale organizations of hundreds of developers or tens of developers at least, all working together in the same code base. And the code base is not organized as it could be. It has grown organically and has become a very coupled mess of a software artifact. So what happens? All people involved have to feel a lot of pain. Developers have the challenge to navigate this very complex code base. And of course, since it's very coupled, things tend to break easily. So changes are always a high risk. This leads to outdated code, outdated frameworks. And of course, developers not getting their job done. At the same time, in operations, this also causes problems because these applications tend to grow and grow. The runnables, the deployables tend to take up more and more resources, and usually they also get stateful, so scaling becomes an issue because you cannot horizontally scale them very easily. And at last, the management is also not happy with this situation because what we typically see in these scenarios is the development is becoming less and less efficient. So the spending on IT resources increases, but the output stays the same or even decreases. And slowly but surely, release cycles get longer and it takes forever and ever to release new features. When this collective pain becomes big enough, it is time to start refactoring these monoliths and to disassemble them. The first pattern that I'm going to present to you today is probably not a surprise. It's a very common, famous pattern to dismantle monoliths. It's the strangler thick pattern. This, coined by Martin Fowler, pattern was inspired by a plant. I think he visited, so he saw it on a travel in Australia. It's a fig that grows around the tree, and it grows to such a size and extent that the tree that it encapsulates is slowly strangled until the tree within dies, and the fig is then able to live essentially on its own. What sounds very cruel in nature is actually, in the case of our situation, a desired behavior. And this as inspiration serves as the founding pattern for what I'm going to show you now. So let's start off with an abstract representation of your monolith. This monolith probably is not, this representation is probably not very accurate because usually it is not as cleanly organized as this. It's usually something like this. Your monolith, a big pile of features all interconnected with no clear separations. And what the strangler thick pattern does is we take parts of the big API, which is usually covering lots and lots of different use cases, and we gonna re-implement these parts of an API in a migrated slice. So so we're gonna take parts of the features of the monolith and create a new slice next to it, implementing exactly those features. How this gonna happen is how you do this is usually one of the most tricky parts of this pattern, because usually the monolith is, even if it's a big pile of coupled code, it usually has some sort of organization and structure. And structure is usually very domain and data centric and essentially efficient within a monolithic code base. But the same structuring doesn't actually have to be suitable in a distributed scenario. So just taking over the structure that you have in your monolith and taking it out of the monolith and using it in your distributed architecture is in most cases not a good idea. So your slice essentially is going to be some kind of vertical that we have illustrated here, which is going to cover different features of your monolith. So this essentially gives you an opportunity to reimagine how your distributed world should look like behind the API you're implementing. At the same time, it gives you a challenge because you have to decide how much can you reuse of the existing code and how much you have to re-implement. Reuse, of course, is very unspecific. In 99% of the cases, it's not something like copy the existing code and using it there, because it's usually very tightly coupled and cannot easily be extracted. So reusing is more, in most cases, more like something like implementing inspired based on the existing implementation. Of course, if reuse is very important for you, you can also try using shared libraries or like a microkernel architecture, but it's usually a big challenge, and it hinders the possibilities you have to reimagine your new world. Because you want to leave the monolith and you want to re-implement features in a clean and more suitable way. And the more you take over of the coupled code base, the less you are going to have breathing room to reimagine your sources. So in this case, we often encourage to, at least to some degree, reimagine the new world and take advantage of the fact that you now have left the deployable, which is your monolith. So for even in some cases, you could even decide to use a familiar but different programming language. Once you have created the slice, it is time for you to prepare a switch. So usually this is like a reverse proxy. And when your slice is ready, you are able to reroute the traffic and use your migrated slice. What happens now is that certain features in your monolith have now been discontinued. So they have not been extracted, but they are just not used anymore. The benefit here is, up to this point, we have not even changed the monolith. So we have essentially always the possibility to fall back if some things go wrong. And we can do a lot of testing beforehand to compare results. Of course, a lot of you out there will ask yourself, this sounds a little too easy. And you're right. Also, this pattern also has its challenges. As I mentioned, testing is very important. So the monolith and the slice need to remain comparable. So at one point, you want to reimagine your new world and re-implement the slice in a more efficient manner. At the same time, you cannot do this into an extent that comparisons become impossible. So changes during your migrations are to some extent limited, but there's still a lot of degrees of freedom. Of course, as I mentioned, finding the right slice is not trivial. We will not talk about this in this Brainfood Talk because this is an extensive topic. Fortunately, our next Brainfood Talk is going to be exactly about this topic. At last, most of these features, 99% of the case, gonna operate on data. So just taking logic out of the monolith is not taking the full picture into account. And that's why we need to also think about how to handle the data, but this comes in a second. So I want to just quickly give you an alternative. If you say, okay, Strangler Fig sounds like too oversized for me because I have to re-implement so much stuff. Okay, an alternative, of course, is to refactor the monolith. And one typical way is using the pattern branch by abstraction. This is not something people who out there of you who have experience refactoring will not be surprised. You just implement an interface between the feature you want to extract and certainly is essentially an abstraction layer. And after you have done that, you are free to migrate this feature even outside of the monolith. The downside here is, of course, you have to do this within the monolith and there is no fallback. So essentially, you have to invest a lot of refactoring in the monolith. And depending on the coupling that I mentioned before, this can also be a huge invest of effort. So I mentioned data. Let's jump to the topic of how to handle data during these kind of decompositions. So as you probably already know, all your logic, or our logic, operates on data. So the migrated slice that we are gonna reimagine or take out of the monolith also will require data. This data can be separated into data which is owned by the migrated slice. Owning in this type means written by the migrated slice, and data which is just required for reading. So to get something straight out of the way, it's very tempting to just share the database. Of course, this sounds like a very fast and short, elegant solution, but usually it's the worst possible solution. You essentially couple yourself to the data structure of the monolith, which is, of course, optimized for the monolith and not your migrated slice. This means that essentially the reimagination options that you have are very limited, because the migrated slice always has to tailor to the data structures that have been created initially for the monolith. This, of course, couples the slice and the monolith tightly together during development, also during runtime. Every time the monolith changes its data structure, the migrated slice has to change as well. And it becomes very hard for the migrated slice to essentially get very independent. At last, of course, data consistency here in this scenario is always an issue. So the risk of having multiple corrupted data here, because the monolith writes data and the migrated slice writes data, increases in this scenario. So what we want is actually a clear separation. We want to enable our decomposition to have its dedicated data structure. We want to have clear ownership separated between the slice and the monolith, and we want to have no change impact between the two. So the monolith can change on its own and the migrated slice can change on its own. How are we going to achieve this? The next pattern that I'm going to show you is co-location through synchronization. So we implement a synchronization pipeline, which is going to transfer the data that is required by the slice outside from the monolithic database into a database which is essentially owned by the migrated slice and optimized for the migrated slice. This synchronization, of course, also could contain transforming. So data structures on the left side, as you see here, do not have to be the same structures as you see on the right slide, on the right hand side. If the data is not owned by the migrated slice, it is read only. What does it mean? In most cases, the migrated slice will require data from different domains which is not the owner of, but at the same time it requires this data to execute its business logic. So we're gonna synchronize data not owned by the slice into its data store and keep it there as read-only data, which is permanently co-located and continuously updated. So this is not essentially a one-time batch job, but this is a synchronization pipeline which is running all the time. At the same time, this pattern can be used to transfer the ownership, because the migrated slice is going to replace some features inside the monolith, which means at some point, and originally the data owned by the migrated slice is residing in the monolithic database. And at one point, it's during the migration, we want to migrate this data, the ownership of the data, into our slice database, which means we're going to implement the synchronization of this data, which is then soon to be owned by the migrated slice. But then after the migrated slice becomes live, the synchronization is actually deactivated. This pattern can be implemented using some different approaches logically. So usually change data capture is used, CDC, or periodic polling. And there are a lot of frameworks out there supporting this. Most prominently, probably Kafka with Kafka Connect and Kafka Streams. There are also others like stream sets. And these, in some cases, are very heavyweight. We want to also mention that Debezium, with its embedded engine approach, can also be a lightweight alternative. Why this synchronization, which seems like a lot of effort? Because it decouples us from the old world and enables the slice to have its own data store tailored for its needs. The scaling is much better because we can scale in the way that the slice is required, and the ownership transfer is much more transparent and much more controlled. Of course, that's a lot of moving parts. So we migrate logic, we migrate the data, we have to touch a lot of things to actually get something out of our monolith. But the good thing is, both patterns actually don't change the original monolithic world. So the monolithic database and the monolithic logic have not been changed up until this point, which enables us to safely perform comparisons, even in production. So we have our migrated slice in production, but not live, so no traffic is received. And here is where we introduce a third pattern called the scientist pattern. This was introduced by Jessie Toth. Our very nice GitHub blog is in the description below. She proposed this scientist pattern to actually automatically compare the new and the old implementation. So the traffic is routed through the scientist, and the scientist calls the monolith as usual. At the same time, for every call, the scientist also calls the slice and compares the results. And these results can then be automatically logged and tracked and illustrated in metrics. And this helps us to compare and raise confidence, because these migrations usually are a huge undertaking. Alternatively, of course, we also can perform canary releases. So these releases, where we only let a small part of our user base, usually called friends and family, onto the migrated slice and let them try out how the slice behaves. And all the other customers remain in the monolithic world. And you can then also, in an automated fashion, if the monitoring looks good, slowly but surely shift the traffic from your monolith to your migrated slice. So now we want to combine all these patterns to form our big picture. So here we see it. Here we see the patterns that I just presented to you. We can extract logic through our strangler slice. We provide the data for the strangler slice through data synchronization, and we track and compare the results of our strangler implementation continuously through the scientist pattern. Why do we propose these patterns as square? Because these patterns enable us to have reversible decisions. Monolithic decompositions are huge undertakings and usually very scary. So it is important to actually keep a safety net for as long as possible. And while maybe to some of you, those three patterns that I illustrated before to you are sounding like a large upfront invest, they actually enable us to try out new things in a safe environment and make mistakes and learn from our mistakes without actually causing problems in the monolithic world. And we can grow and learn from these mistakes up until a point where we have enough confidence that we say we have successfully extracted logic out of the monolith and we can safely switch to the new implementation. And in most cases, we even have then for some time a fallback scenario. Now, for the last part, I wanted to mention these transformations are typically not just a refactoring, but they touch all kinds of stuff. They touch our infrastructure, they touch our teams and communication, our release automation, and decision processes. So it's not just taking a piece of software and refactoring it. A monolith of a size that I have described in this presentation is usually highly optimized and embedded within an organization. So everything around it is optimized for the monolithic structure. And when you go ahead and decompose the structure, you have to think about all the other areas illustrated here, how they can be adapted and changed to enable the new decomposed slices to also be as efficient as possible and to essentially gain the benefits of having having a lower time to market and having a more efficient IT investment, as I mentioned. Last advice from my side: it is important to get started early. it's no use to overanalyzing this topic too long. We have seen a lot of projects where monoliths and monolithic transformations are analyzed for months and even years, and there are no clear results, because these undertakings are usually very complex and it is not possible to get a full picture beforehand. So it's going to be a long journey. That's why it's just important to agree together on clear goals and get the management commitment for them. And then it's important to get out there and start coding using the patterns that I just showed you, which we as Square use by our customers in our projects for our customers. So that's the last piece of advice I want to give you. Thank you for your attention to our Brainfood Talk for today. The sources for this talk can be found in blog posts that are linked in the description. The video, of course, will be available as well. Don't forget, this series is going to continue, so I can highly recommend the mentioned Brainfood Talk. Upcoming next on the 8th of April is Clemens himself with his Slicing the Microservice Efficiently talk. And also, we're going to host a conference this year on May 18th until 20th. The code graphs is going to be great. Don't miss it, and check out our homepage about that. Thank you for your attention. Now it's time for your questions.
Yeah, thank you, Christoph, for the very nicely abstracted walkthrough through monolith decomposition. There is a good bunch of questions that we can go through in here. I'm going to go through them in order as we had them come up during the talk. So let's just get right into it with the first one. And I think it was with the reroute and discontinue pattern that you introduced. The question is, where does my authentication go? And follow up, how do I deal with sessions once I'm out of my monolith?
A very good question. So usually the goal here, also the additional challenge here is in most monoliths you have a stateful situation like the session you already mentioned, and in the new slices, what at least how I have seen it, we usually strive for something more stateless, so no session content held there, but authentication token based like OpenID. And what usually you have to implement in this scenario is you have to implement some kind of transition between your tokens and your session on the monolith side. So what usually happens is for each token that you establish to access your new slice, you have a component in your monolith which also establishes a session for that, and in order to keep them in sync if need be, in order to also enable you to jump back. But this, of course, is there is no how can I say, there is no blueprint solution for every situation. This, of course, is highly tailored for your in every situation depending on your infrastructure.
So did I get this right? I would have some upfront place that I would need to get my session logic out first.
I mean, first we got depending on the question, I assume that the session logic is handled within the monolith. So in the new world, you have to ask yourself, do you want to keep that in the slices? Do you want to keep authentication and authorization in the slice, or you want to keep, or do you want to manage this maybe somewhere outside of the slice, maybe through a gateway, and or do you want to keep that in the slice? And of course, from our perspective, the slice authentication should be token based. So you have to ensure that the way the tokens are issued are in sync with the sessions that are created in the monolith.
I hope that sufficiently answers the question. If not, please just follow up. Then, second one, again from X3Y, which is concerning branch by abstraction. If I pull out the refactored parts in branch by abstraction, say I pull out the user repository, am I not creating a distributed monolith? Is that a good idea?
That's a very good point. So we brought up branch by abstraction to showcase an alternative to the strangler fig pattern, because in some cases, strangler fig pattern might seem as too large of an invest upfront. But yeah, this is essentially a challenge that you have here. Usually the structure you have within your monolith is not suited to be used one-on-one in a distributed setting. So you are not gonna have your customer domain, your user domain, your contract domain at one deployable in your distributed setup. This makes sense to have in a monolith, but not, as I mentioned, in a distributed fashion. So you would actually not extract one singular domain of your monolith, but you would have to already create your crossover domain if in your branch by abstraction refactoring, which is essentially tailored to be used in a distributed fashion in order to avoid falling into the mentioned pitfall that if you're falling into the mentioned trap that you said of creating a distributed monolith.
Next one is still the same, very busy user, X3Y again. Is it really such a big deal that I reuse the data structures of the monolith? If it's just a downstream service, think reporting, is it a clear no still?
Yes. This is so even in reporting, so usually you want to have some kind of decoupling. So if your database is small enough, you can copy the database for your reporting. Then you have the databases separately on infrastructure level, because the first issue here, of course, is in production is performance. So the reporting is essentially gonna snag the performance of your productive systems. And yeah, the same. Then the next thing is the change impact. So you usually want to have your new world to be very fast and flexible, and you want to have a very, very short time to market. And you're not going to achieve that if you have to essentially tie yourself to the structure of the monolith, because what you actually do is you tie yourself to the change cycle of the monolith. So you have to say essentially a situation then where you have a deployable, doesn't matter if it's reporting in downstream or something more complex, which has to change in the way that the monolith does. And the monolith doesn't care about your use case. So reporting is all about taking out, aggregating results efficiently, and processing huge amounts of data. And usually you use very tailored data structures for that. In the monolith, this usually is not a concern for the operative use cases. So you usually have a data structure which kind of tries to serve all of the needs at once and fails typically to serve all of the needs required. So yes, even in reporting, I would say decouple that.
Yeah, as you mentioned, also from a performance requirements perspective, right? Like, what does this database system, what feature set should it support? And that also differs based on the use case. Thinking of big data, business intelligence analysis is different than the ad hoc production use cases usually. Great. Next question coming from Gregor Riegler. How do you deal with potential inconsistencies coming from the data split?
The potential inconsistencies is like a very general aspect you mentioned. So one of the things you have to think about in a distributed system is, of course, the point of eventual consistency. This to developers and architects who are used to live in a monolithic world, at first this sounds super scary, because of course the monolith gives you some advantages. One of them is you can create huge commitment, so you can huge transaction frames where you can pack in a lot of stuff and you get the ACID criteria out of your monolithic database. You cannot do that anymore in a distributed setup. But this is not more of a question of do we actually apply Strangler Flick or data synchronization, but this is a question about how are we going to live in a distributed infrastructure? How are we going to ensure that? But there are ways to do that. You just can't approach the topics in the same way as you did in the monolith. So usually you don't want to have distributed transactions. That's why you create some state tracking. If you really have to pass on data between your services, and you have to wait for results or something like that. And you have to accept these pending states as a normal part in your data logic and not as a blocking part in waiting for response. The mentioned approaches of focusing on ownership is the first step on the way here to ensure that everything goes right. So usually the topic of ownership is not clear in monoliths because it doesn't have to be. It's a very fuzzy thing. And during your transformation, the first step of thinking about how you can solve these new challenges is to edge out which parts of your data domain has to be owned by whom, and which parts of your data domain have to be reimaginated. So the second aspect of this is you don't have to actually transfer the data domain as it is. The same way you don't have to transfer the code as it is. You can also reimagine the data domain. For example, you can split your customer domain in leads and existing customers, something which is usually mixed together. And then you avoid some of the consistency challenges by rethinking how you treat and collect your data. Sorry, long answer.
Yes, but it boils down to you have to change your way of thinking about it. So stop thinking about transactions. You can have transactions within one area of ownership usually, and eventual consistency is not a big scary thing. It can be dealt with. It is just a different problem to deal with than we're used to.
True.
Now I'm going to skip one of X3Y's questions to get to other people as well. So Herbert Feller asks, how does embedded Debezium work in comparison to running Debezium as a connector in Kafka Connect? Was not aware that there is an embedded way to use it.
So I actually have to admit that I have not that in-depth technical knowledge about this approach, but we utilize it in our projects, so we can follow up on that. But the way I understand it is that the main difference here is for the other approaches, as I mentioned, you need dedicated infrastructure, dedicated deployables. And in embedded mode, you run in the same deployable as the data. So the data integration runs in the same deployable as the logic, as the logic that the data is fetched for. So if you have your migrated slice, which is a Java application, the embedded Debezium is running as a separate part in that virtual machine to perform the data integration for you. So essentially, you save a lot of infrastructure and deployables on the way. I hope this is correct 100%, but feel free to contact us. We can give you more details as a follow-up.
All right, Herbert, I hope please just get in touch if there are more questions, or maybe even post another one in the chat now. But the next question is also from Herbert. how would you split teams if you move from one monolithical team into multiple teams owning separate services?
So this is a good question. So usually what you want to achieve in your new slices and your new services is a sense of end-to-end responsibility, which is in most teams, as I know, in monolithic infrastructure is not the case. In monolithic applications, there's a lot of specialization going on, with teams focusing on just parts. And so the way you want to approach this is not taking out one team at a time, but you have to take out the people out of the team. So you, as usually, start with one individual slice, and you create a novel team which consists of members of multiple of your monolithic team, and to work together to get a vertical slice running, because you want to have that mixed knowledge. You want to have that specialized knowledge broken up apart and mixed into your new service as one, in order to have this end-to-end responsibility in your new team.
Exactly. And you want this end-to-end responsibility in one team, because usually the team boundaries lead to a lot of delays due to backlogs, synchronizations, etc., and knowledge or communication not flowing quite as freely across team boundaries as it does within one team.
Yeah. I know this is essentially a same challenge as a big challenge as the technical refactoring itself. That's why I mentioned it's not just the technical refactoring, because this usually touches organizational structuring and hierarchies. But in order to comply with Post's law, you have to think about these team structures and communication channels. If you just take an existing team and move it out of the monolith, there is a high chance you just create a distributed monolith.
All right. With that, we are at the end of the questions here. So far, I have not seen anything else roll in. And with that, we've also reached the end of our Brainfood Talk. So it was nice of you to join in. We're happy to see you again. Next one is going to be hosted by me. I hope I can reach the high bar set by Christoph now. But to close out for now, wish you a nice weekend, an enjoyable rest of the Friday, and see you the next time around. Goodbye.
Thanks for joining, everyone.